Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join the Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize a cone. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be presenting to the children. We are going to visualize a cone. We'll tell what is a cone. We will take the points and cone will come. We will show them the radius, we will show them the height, we will show them the slant height. We will tell them the formula for lateral surface area, total surface area, and ask them to calculate the total surface area, formula for volume, and then asking them to calculate the volume. And then by moving this height and then selecting the radius, they can check out what will be the slant height and what will be the volume and radius corrected to one decimal place. And by rotating it, they can visualize what is the meaning of lateral surface area, what is the meaning of total surface area, and so on. Let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet. I have selected geometry view. In option, I have selected rounding off to one decimal place and labeling of new points only. We will have this 3D graphics view. Because we are going to do most of the things in the 3D graphics view only. We'll make it little bit big and we will remove this axis, we will remove this plane also. We will start with the definition. The cone, we are going to visualize it. The definition of the cone is a set of lines which connect the common point called the vertex to all the points of the circular base. These are the two interesting things about the cone the child has to remember. Okay. Now let us start with fixing the radius. Therefore, we have to come back to graphics view because slider is available only in the 2D graphics view. It is not available in 3D graphics. Therefore, you should be a bit careful. Slider. Put the slider. We will have the slider for radius. We can have the minimum as 1. The maximum as 10, it is left to you. You can have it at 5 also. Then increment as 1. Then we need the height also. So let us have HEIGHT, height. Then let it be from minimum 1 to maximum 10 with increment as 1 and then okay. Now I got the height also. Okay. We will start with forming that cone now. For that, click this 3D graphics. Click the 3D graphics. Here you just take any point, maybe at a convenient place. For example, let me take it over here. Now the point A has got. Now I want to have another point which will be moving along with A, which will become the height of the cone. Therefore, for that, I am going to this view. Go to this input bar. Now, simply type. You can simply type or capital B is equal to whatever you want. Capital B is equal to x of small x of capital A, then comma capital Y of capital A, comma then the height HEIGHT. You see all of them are going in blue color. You should be a bit careful and then I'm pressing enter. Now what will happen when I move this height is also increasing. Okay, now 2 points I got. Let us go back to that cone now. What the cone tells, it tells that select the bottom point and select the top point and then enter the radius. Now I want the cone should be on the top point, I want it to be capital B and bottom point I want it to be capital A, or you can have it as OA, whatever you want. Therefore, I am touching the bottom point. I am touching the top point. It immediately asks the radius. Therefore, in the radius, I will give RADIUS. Okay. Now I got the cone now. When I move this, the radius, the cone is got it, then height also I get. Okay, now highly interesting. Okay, now what you can do is, if you want to have this base to be shown separately, you can go to this object property. Okay, in that color you can have it as little bit blue. The color is to be selected by you. Opacity you can have. Therefore a child can now understand that what is the base and what is it. Now if you want to show its height, suppose go to the line segment, you can touch it and then this will show you the height. If you want to show the radius, you can take a point here. Then once again you can go to the segment and you can join. Okay, first we will try to show the slant height. You see, this is the slant height. You see, you got the slant height. Okay, slant height you got. If you want to show the radius, once again go to this segment and then join this C and E. Fantastic. Now a child can understand that what is the slant height and what is the height, and a right angle triangle is formed over there, then they can understand everything now. Okay, now the thing which you have to be very careful is we have to express everything to the children. Therefore you have to write radius is equal to from the object you have to take radius. Okay, now the radius is 3. Okay, once again height is equal to, okay, from the object height is equal to 5. It is being fixed over here now. Now the slant height we want, let us see what is the variable given to the slant height. Right click, it is G. You have to remember it is G. Therefore again you can go to this ABC, then you can have slant height is equal to, from the object you can have it G. You have to, I think just now we got it, 5.8. Okay, highly interesting. Also, all of you know that this slant height will be a perfect number when this is 6 and one of them is 8. Oh, it is square root of 100, therefore you are getting it as 10. Okay, anyway, I think this is the only thing which I just want to play with the children. That is whenever radius and when it will become a perfect number. Okay, well. Okay, now you can go for 3 numbers which forms the Pythagorean triplet also. You can ask them just what is the Pythagorean triplet, then you can keep it as 3 and then keep it as 4. Once again it is a Pythagorean triplet 3, 4, 5. Okay, anyway, this you can just play with the children. Okay, well, now let us try to express one after the other very quickly. Okay, we will tell them that what is lateral surface area is equal to, now we can tell them that it is pi RL, pi multiplied by radius, okay, again multiplied by, then you can ask questions to the children, they will tell you that what is it, slant height. Good. Okay, now they got the formula for the slant height. In the input bar you can have LSA, sorry, okay, no need for it. Okay, LSA is equal to, now you can have the formula 22 by 7, okay, multiplied by the radius, and then what is actually we got it for the slant height, it is G. You have to remember that. What is the variable here for the slant height? You have to just simply enter it. Okay, you got it. I think this is the construction protocol. It has opened automatically. I think we don't want it, but we can close it also. If you don't want it, you can close this construction protocol. Construction protocol means actually it tells you that in what way you have done it. Anyway, let us go to this lateral surface area. Already we have calculated. I have just calculated it as LSA, therefore that value I have got. Okay, now you can ask the children to check it out. Okay, now we will just go for the next total surface area. Now you can ask the children that what is the formula. Now the formula is pi r square, because there is only one circle is at the bottom, therefore pi r square, from the symbol you can use this square, okay, plus lateral surface area LSA. I think you can tell the children that how they got it. You can explain the formula also. Okay, once again you can, in the input box, you can write TSA is equal to 22/7. Actually this value is already available there as C, but anyway I am doing it once again. Multiplied by 22/7, okay, multiplied by radius. How to get the square? In that alpha you will get this square, radius square, okay, plus LSA, okay, LSA. I think already you got it now. LSA we have already found it. Therefore you can go to this ABC and you can now tell that what is TSA. TSA is equal to from the object you can have this TSA. Now I think TSA you have got. Now the next one we can tell the formula for volume. The volume formula is having one fraction. For go to this latex formula. In this latex formula, go for this 1/3. I think you know that it is 1/3. 1/3 pi r square h. Therefore multiplied by pi multiplied by radius square, radius, radius and square, okay, then again symbol multiplication into height, okay, 1/3 pi r square h. You can type 1/3 pi r square h also, but here I have used radius, therefore I am making use of that idea. Therefore now capital V is equal to 1/3, therefore 1/3, once again in the bracket 22/7 into radius square, radius. Then again how to get the square? From here you have to go and click this square, multiplied by, you can use the word star into height. Remember, whenever the word, the same variable which you have used here, radius, heagt, like that you have to make use of here also, because they are the sliders. Okay, 1/3 pi r square h. Okay, I have done the enter. Or I am going to this ABC. Now I will declare that what is the volume. Volume is equal to capital V. Therefore volume is equal to capital. Okay, I got it. Volume is equal to 1/3 pi r square h. Okay, now a child can come and he can change the radius and he can change the height. At a particular spot, he can calculate what is the slant height and what is the lateral surface area. He can rotate it and then check out what is the meaning of lateral surface area, what is the meaning of total surface area, what is the meaning of the lateral surface area. Everything he can visualize it. But it's a very interesting worksheet which tells a child about everything about the cone. What is the cone? What is the meaning of its radius? What is the meaning of its heights? What is the lateral surface area? What is the total surface area? And what is the volume? It always gives you the formula also, and giving the child the way to express it also. In the navigation bar you can have, so that from the beginning you can explain to the children what is a cone, how the cone is obtained, and you can lateral surface area. Then one by one you can explain it to the children. Thank you. Let us learn to lead.